All right, in this video, we're going to go over the Unit 7 free response question part A, number 1 from yesterday. I know these were a little bit tougher, and that's okay. Hopefully going through this will help, and also, we'll do a little bit more similar ones today. So here we have we're given a differential equation, dA dt equals 6 minus 0.02a. We're told that t equals 10 minutes, or at time t equals 10 minutes, a, the amount of salt is 50 pounds, and so this dA dt is a rate of change of the decrease in the amount of salt. So first question told us to find a tangent line at time t equals 10 to the graph a, to the graph of the function a. So to do that, so tangent line, almost certain you'll have something with a tangent line on the actual test. We need a point and a slope. Don't overthink it. We are told the point, 10 minutes, 50 pounds of salt, 10 comma 50. We need a slope. Well, that's what the differential equation's for. So we're going to take that dA dt and plug in, and be careful here, a. So at t equals 10, we're going to plug in 50 for this a. And so when you do that, we end up with 6 minus 1 is 5. Here's another problem where I don't think they would give you these numbers on a no calculator question typically on the AP test, so I don't think this would be quite this bad on there, but you will have a calculator, so that's fine. 6 minus 1 is 5. They don't ask for, oh no, we're doing the equation, sorry. And so then we have the point and we have a slope, so we can write our point slope form equation. Y minus 50 equals 5 times x minus 10. Then it asks us to approximate a when t equals 12. So we're going to use that tangent line to approximate a. So the first thing I would recommend is, it's kind of like we're changing y to a. So I would say that a is approximately equal to, and then you can just use that equation above and plug in 12 for x. So I added 50 to the other side, and you get 60 pounds of salt. So that's part A, part A. For part B here, and this was probably the hardest part of this problem, I'm going to go on a little side example here to try to help understand what we're trying to do here. It says, show that this function a of t, 300 minus 250 e to the 0.2 minus 0.02t, satisfies the differential equation we were given originally, and including that a of 10 equals 50. So, to try to put this into context that maybe makes a little more sense, what if you were given this equation? Square root of x plus 3 equals 2y. And then I told you, here's a solution. X equals 33, y equals 3. That your job is to show that x equals 33, y equals 3 is a solution. So how would you show that? Well, you would take those solutions and plug them into the original equation, right? And you would show that you get square root of 33 plus 3 is 36 equals 2 times 3, and then you get 6 equals 6. So it works, right? So what we've done is we've showed that this equation is these are solutions to that equation. That's essentially what we're trying to do here, okay? We're trying to show that this is a solution. So here's my original equation, here's my solution. So ultimately what we're doing is we're plugging this into there to show that it works. But the other piece of that is, when I do that, I get dA dt equals stuff. And so I have to also know what this dA dt is. So what I started with is, well, first you also have to show that a of 10 is 50, and it works. You just plugged in 50. Then I'm going to take that a of t and I'm going to find its derivative, so I can find dA dt. Okay, so you take a prime of t, and you end up with negative 250 e to the 0.2 minus 0.02t, chain rule, so times the negative 0.02, And if you multiply that out, you get 5e to the 0.2 minus 0.02t. So we have this dA dt from this equation, and I have this original dA dt. So again, I'm trying to show that it's a solution to that. So I'm going to take this and plug it into there, just like we plugged y and x into the equation on the other side there, as the example. So when I do this, I'm going to take this, and essentially it's like this is the dA dt, and I have to show that it equals this. So 6 minus 0.02a, well, what's a? It's this original function. So I'm going to plug in the original a function into dA dt. So I get 6 minus 0.02 times a, and when you distribute out the 0.02, you get 6 minus 6, and that works out nicely. We get dA dt equals 5e to the 0.2 minus 0.02t, which is the same as we got here. And so that's how that works. For part C, this is a simple separation of variables and use the initial conditions you're given to solve. So I'm going to start with moving the square root of h to the left side with the dh, and so that's h to the 1/2 on the bottom, and then the dt, the k will stay with the dt. And after we do that, I'm going to integrate both sides, change the h to the 1/2 to the h to the negative 1/2. Integrate both sides, that gives us 2h to the 1/2 on the left and negative kt plus c on the right. Now I'm going to use those initial conditions. So I can find k and I can find c. Usually something with 0 is what you want to use first. And so we'll plug in, I believe I started with t equals 0, h equals 16. You solve it, you get c equals 8. And then 30 and 4 allows us to solve for k. K is 2/15. And then we just plug in and isolate h of t. So there's a few different ways you could have your answer look. Yeah. All right, hope that helped. Thanks.